Alright guys, in the last video we were just talking about a regular geometric series. Now we're going to talk about a special situation. Whenever I'm going to ask you to add to infinity, a couple things actually have to happen first. First and foremost, let's just look at the equation that we have here. It's the 1/2, well 1 plus 1/2 plus 1/4 plus 1/8 plus the ellipse, the dot dot dot. That means it's going to go out to infinity. First thing we need to do is we need to identify my a sub 1. So my a sub 1 is still just my first term right here. So this is my a sub 1. Then I need to calculate my r. We're going to take two consecutive terms. So like 1 and 1/2. 1/2 and 1/4. We're going to take the second term and we're going to divide it by the first term. So when we do this, the first time we're going to do, we'll have 1/2 divided by 1, which is just 1/2. Now we can't stop there because that would just be a unique difference or a unique ratio, not so much a common ratio. That's why we want to do it at least twice. So next one we're going to do is 1/4 divided by 1/2. Well, when you divide fractions, you're really multiplying by the reciprocal of the second fraction. So this is actually 1/4 times 2 over 1. Well, conveniently, 2 goes into 4 twice, so we get 1/2. So 1/2 is indeed our common ratio. Now, before we can add to infinity, we actually have to come over here and look and see if I take my r and take the absolute value. So my r is 1/2. So if I take the absolute value of 1/2 is 1/2. If 1/2 is less than 1, this series is said to converge. These little three dots here means therefore the sum to infinity exists. That means we're going to be able to add it to infinity. However, if you find your common ratio and you do the absolute value of your common ratio r is greater than or equal to 1, it diverges. Therefore, the three dots means therefore, the sum to infinity does not exist. Before we actually add this to infinity, I want to go ahead and just write this in sigma notation. So when we write anything in sigma notation, it's going to be the same as with the regular geometric series. We need to go ahead and have our sigma. We're going to pick a letter. I want to say K, and you're going to start at 1. But in this time, up top, right here, we don't have a number that we can actually end with. Like we're not going to add to like the 15th term or the 30th term. We're going to add to the nth term, which our nth term would be infinity. And then, of course, right here in our brackets, this is our nth term equation. Which in this case will be our a sub 1, which is 1 times my r, which is 1/2. And in our nth term equation, it says n minus 1, but because my letter is k, we'll do k minus 1. So that's how you would write this to infinity. Now let's actually add this to infinity. On your cheat sheets for your formulas, you have the formula, the sum to infinity equals a sub 1 over 1 minus r. So we know our a sub 1 and our r, so we just plug it in. My a sub 1 is 1. We do 1 minus 1/2. When we do this math, we end up getting 1 minus, or 1 divided by 1/2, because 1 minus 1/2 is just 1/2. This really means 1 divided by 1/2. And once again, when we're dividing by fractions, we're multiplying by the reciprocal of the second one. Therefore, this becomes 1 times 2. Therefore, when I add this to infinity, I get 2. So this actually equals 2. Up here, this would equal 2. And of course, then here would also equal 2. So when we add this geometric sequence to infinity, we will get 2. You need to make sure, though, that before you start adding to infinity, you check your common ratio, that your common ratio has to be less than 1 for it to converge. If it diverges, you cannot add to infinity.